Hello, everybody. The issue that I'm going to discuss here is the proof behind one of the ways, or maybe the most primitive matter, seemingly, to consider for the Pythagoras theorem. We could call it another name, like over here. So, it's based on a right triangle. What's special about it is that the distances the person would have through such angle would be independent from any other line that could be formed. So let's see here. If someone would need to go this way, there is an angle that will be formed like with the horizontal line. This straight line, it could be like a path someone is walking upon. Relative to the straight line above this, toward the sky, above the head, the person like would move a certain direction. But if someone wants to relate both distances uh, in an efficient manner that's neither linear toward the right or left, that would be a perpendicular line. This would have its application as well in not just like in math but in other fields. But a simple way in order to relate a position of a certain point through certain distances to an axis of two lines, that would be called like a coordinate system, would be one that has the axes perpendicular to each other. That would form a right angle. That would be related as well to the concept that just the least distance from point to line would be would be a line that's perpendicular to it. Uh, so in relation to the back to the issue here for a right triangle, the observation that someone would have, which could be like graphs from nature as well. But if someone want to draw some virtual and abstract concepts of it, someone could observe that for a certain angle, which a straight path would have its course on, someone could draw another line, and that line after a certain time would have a certain height from the horizontal line, the path that the person was walking upon, and that height after for the same path would increase, considering the line that we're using for measurement, it has the same angle, this angle. So someone through such observation would notice that there should be a relation. Uh, there is seemingly there is some proportionality between how far the person would go beyond through that angle, through that tilted line, relative to the height and to the path someone will be assuming. But what that relation is with the subject of this recording, And now, so the person should have some abstract consideration of the matter. So here we're drawing a right triangle, and there's an area associated in it. This line, let it be A, or like this line, let it be B, and this line, let it be C. So the area over here that is related to both of these lines, B and C, how far the person would go beyond this line, how and the height of it from a certain viewpoint are related to how far the person would assume the path on the tilted line A. That could be of this distance, could be of a greater distance. You could call another designation, but there's a relation seemingly. And the way the person would think about in order to attain this relationship is that there's some chorality here between B, C, and A. If this part is like B times C over 2, which could be explained in another recording, then how could that be related to A? The matter that the person would constitute that is that he would try to make a simile here. So there should be an equation between A within a certain manner. There is a function of A between a function of B, a function. So function is just a way to relate terms in a certain manner, certain operations, multiplication, division, exponential raising of certain values, or doing some square. So in this aspect. Making some selections here, trying to move them if possible. Okay. But B and C are related in a geometric manner through an area that would be swathed by B and C through a right angle, having this deviance form through A. So how A could be related to the two-dimensional object is that we would construct also another two-dimensional object that's based upon A itself, and it could relate B and C as well, but the matter then, if that would be the case, could be more complicated through algebra, the terms needed in the equation. Now we're heading to construct another geometric object that would compose A, so that a relation could be based upon it. And it should still be related to B and C in a manner that we would attain a final relationship. So the main course here is just to construct another object. So let's see here. We could draw, let's try. We could draw another line. And it could either be, let's say, it could either be of an acute angle less than 90, or it could be of other forms. But as to the acute angle, someone would notice then that other unknowns would be included in the equation. Other sides would be considered, in other words, as the length of this side. So the area considered by this triangle would include both of these lines and this line. And this line length could be derived through the angle formed initially by this formed from after considering the deviance of this angle. But that would mean here that there should be a relationship between both of these lines and the third line, which we do not have as of this time. But if the matter is like a line that's perpendicular to this line, to line A, then the issue would be more simple. Because as someone would observe, it's like a square could be formed from it. Right angle after another right angle through going through this rotation would form a square. And then other means considering or drawing a line that's like perpendicular to the first line would be like considering something that's more independent to rely the relationship upon. The explanation could go through more details here, saying that it would relate to the concept over here. The two lines, in order to orient in a manner that's independent from another way, and someone should go through a right angle. So to apply these concepts over here, we would form this line. That's of a right angle relative to line A. So this angle is right. And now we would consider the other means to see what relationship could be formed now. Now we would orient in the same manner in a repetitive manner, in a repetitive matter, uh, and form another line in a way that the geometric shape that we would have could have an area, so that was the main object of it, to relate both of sides of the equation, the function from B and C, which is the right triangle, and the function of that could be formed from A, is that to have uh, apparently a square which area is known, and it's the way to prove it could be like explained in another video. So this square that we have obtained so far could then be related to it could be related to this triangle through some observation. So now the thing what we're having here is that we're repeating a certain course. So this line is maintained the same. It's of length A. Let's draw it more clearly over here. It's of length A, 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 and now the thing that we have to consider here is to try to draw this triangle again, in order to maintain a relationship between A, B, and C, and the way we could construct the other object, which would be this square. So let's see over here, after raising this side, if I'm gonna extend this line, then relative to the first drawing that we had, this triangle, the deviance that we have, this angle, the deviance will be equal to this angle over here, this angle. This means that after B amount of walking on this path, there should be a height formed of C amount as well, of C amount. And we were seeing how the thing would evolve in what we're drawing in order to attain to attain a relationship between A, B, and C through geometric means, because here as we explained, there's like a right triangle has a certain area which which should have a relationship with A, as we explained earlier, height to a certain extent, passing path to a certain line through some deviance are related. There's like some proportion. So to go back again, to continue constructing the figure, we would consider here um, another deviance. Let me see. So here we're trying to do it as much as possible to scale. Um so as it will repeat at this side over here, the right angle will be formed this way, because this angle will be the complement of this angle, and with this being a right angle, because of both of these sides at optimum construction relative to each other as to the distance apart in this way. Which will be the manner of doing any system. Um, System of axes, or to locate a certain point, or just to indicate how much certain point would be apart from another line. So in this manner, we'll be having this height, this height, well, the thing that we're observing is the same sides are repeating, because we're considering the same line A deviating of having then the other complements of it to form the same right triangle. So just to make things clear, this is line A, this is line B again, this is line C, the same angle of deviance of the straight path is formed. The same course will be assumed again. And to the final form of rotation that we have been having, to form this square, we would also have the same right triangle relationship formed because there is the same deviance through the same side. So the way to draw it over here, and now picture is complete again. So it's just a matter of that couldn't be made. Then let's see. Okay, so it's a certain way of making things more clear visually. So the sides that we attained here, that we formed, apart from A, are B and C again. So as of this point, as of this stage, we were able to form a geometric figure from A that could be related to B and C geometric figure. And the thing here is that the procedure is repeated. And as could be noticed, these right angles that we obtained aside from this one, so as to base this scribble, form a quadrilateral that's indeed a square having a side of b plus c. So it's always a deviance that would form b, there's c here, b plus c, b plus c, b plus c. So that's indeed a square then, because of the same side as here, as here obvious. Now here we're trying to find a relationship between this area over here the area of this square with the area of this triangle. Because the area of this triangle is could be based on B and C. And the area of this square is considered upon A. The main purpose is to find the relationship between A, B, and C. So how could these sides be related through a right triangle? But the thing that we have attained is another larger square of side B plus C. And such observation will lead to a certain to a certain relationship. Someone would say that this area, after some observation, plus this area, plus this area, plus this area, plus this area would equal the area of the larger square. This area, the area of this square of side B plus C. So we were able to form a relationship then between an operation, algebraic operation from geometric observation, this square, and these sides B and C. We'd have then to try to see if we could able to grasp a proof from it, the so-called Pythagoras theorem, which is the concept beyond other complex equations and formulas and relationships in geometry that could be given some algebraic terms as well. So let's try to write here something. So the thing that we would have here is that we're trying. We hope that would give us some relationship null, like so some null stuff like 0 equals 0. Um, the thing here that we're trying to see the give us some hope. Um, is that this area is independent of the larger area, larger square, but they are related. And this way, because concepts are different, the way this figure was constructed was on a manner that would trying to find another area. That could be related to B and C, but wouldn't. But would not include them like in the same process. The area of this square could be has its equation to be formed that's independent of this triangle. In this way, we are having an attempt to find the relationship between A, B, and C through a way that has different concepts to explain. So we wouldn't attain something then seemingly that would have um, a null meaning as 0 equals 0 in the proof process. Because this area is aside from this area, and as from other right triangles formed, so being there's like some border between them, and whatever is based on them would be something of a new nature that has the same independence, and something of value could be obtained from it. because it's not something internal like as it would be had the drawing been um, let's say this way, in which which would be like having some obvious consideration where with a triangle let's see here, or the triangle over here would have its other figures, but it doesn't yield anything seemingly. So this observation should yield something, the way the matter was constructed, because we attained another figure based on another independent figure through a consistent manner, BC, 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 the same side. Uh, Now let's try to find some relationship based on the geometric observation um, that a larger square would that we obtained would be related to its components. And the hope is that we could find something between A, B, and C. And we should, as we explained. So it shouldn't be like 0 equals 0 equation, which would mean that the concept that we used for to have a certain equation is the same as that to the other side of the equation. Concepts here are different. We've built a square that is nevertheless related to the triangle that we first started with. And now let's go, after this clarification, seemingly, to the mathematical operation that we could have, and as we explained. So the area of the larger square of side B and C is by formula. Let's see here. That's the second exponent. Which could be explained in another video. Should equal the area of its components. We have here four triangles, and the area four right triangles, and the area of each would be the multiplication of both sides over 2. So half of B times C, which basically if the thing could be extended, let's see here. If it could be extended this way, let's see, it will be half it's not drawn to scale here, it's trying to make it more clear, so this way it will be more obvious. Will be half the area of the rectangle, and the area of the rectangle will be the multiplication of both sides, which could be proved in another video. It's just a matter of observation. So to undo this stuff again. So this was like a sum node, why the area of the right triangle apart from the hypotenuse is half the product of its sides. To go again to the proof algebraically, the thing we're having here is the larger square of side B plus C having its components, the smaller inscribed square and right triangles. There's 4 of them. So the thing we would write here is let's see, is that we have multiply 4 by the area of these triangles, which would be B times C. So let's write it in this way, B times C over 2. And we would add to that the area of the square, which would be the side times the side square raised to the second order. And now having this equation formed, way to relate both areas, which is based on these sides, we would definitely obtain a relationship, because this construction isn't dependent from each other, though it have the same form. We were trying to orient the path 90 degrees in a repetitive manner in order to form a geometric figure, which area could be related to this area of this right triangle from B and C. Because as we observed earlier, that there should be a relationship between A and B and C, because the deviance that we were having through this line tilted from the straight path, call it B, to this extent, that could be extended, is that it has some proportion. The height would increase. So with the straight path length, as we deviate more. So these are related. I was trying to form another construction that is independent, that has its significance, and we made it in a right angle manner, so that we would be able to form something based on another, because I had it been in another deviant course, the thing that we obtained is another line which we're not trying to draw again, but it was another line, and then we would need seemingly a relationship between the three sides of a triangle in order to form its area. But the only thing that we have is the relationship between two sides perpendicular to each other, in which that we would obtain then either a square or a rectangle, and the area of the rectangle or a square, based on the formula that is known, could be applied here. Anyway, that we would use it to get the area of the new square, or new figure we're trying to have, new geometric figure. In this case, it should be a square, because this side is repeating the same manner through right triangle orientations to go back to the same spot. And the other deviances that we have are the same. And the thing that we obtain then would be a set of sides of the same length upon every deviance, b plus c each time. The thing that we noted here is that the area of the triangle was used to know the area of this, the area of the rectangle. It was used to know the area of the right triangle, and through the same concept of multiplication, and the area of the square formula was used to get this area over here, because we obtained a square, and when we were doing a right angle deviances after forming this triangle. But the thing to know is that this concept of having a deviance that is independent from both sides would precede considering that there should be a relationship and an observation that there should be a relationship between B, C, and A, or sides of a right triangle. And it's something that could be observed by nature, so because there is some horizon that someone would have to consider if someone would walk like say straight path, and he would like observe the sun as it would approaches the midway between the dawn that we would have its arisal at the dawn until it reaches or the sunset, considering it to be it should be the sunset, considering it to be at the zenith. If this is the zenith, so halfway between the sunset and the sunrise, this would be the sunset, and it's going this way. So this way, halfway would form a right angle, considering this orientation. After some approximation, obviously, because Earth is not. It's not obviously not flat. Some would consider some other observation apart from what is taught in school. Uh, and it has it could be proved as well. These became like as a second nature, but someone has to consider the way uh, to prove them, to give them some meaning. There should be some consideration to the basic points uh, as possible. Uh, so back to this expression that we obtained here again, uh, which is valid, and it should have some meaning. Uh, after some some simplification, there should be a relationship that we would have from B, C, and A. Um, so we have like here trying to relate it to its components. The thing that would have as a relationship between B, C, and A should be hidden in this equation. Because this area, are based on these sides that are related in a certain manner, as we explained. Uh, the deviance has its proportion impact upon the length sides. So let's try to do the algebraic simplification here. Um, so b plus c squared operated would give b squared would give 2bc would give c squared. Let me see here. Let's try to do the text again. There was an error. I'm sorry for that. It would give b squared plus c squared. It's a matter of expanding a binomial plus 2bc. On the other side of the equation after simplification we give 2bc and a squared. B squared. 2BC. This would have its algebraic meaning through certain shapes. Uh, I mean, this would be BC. Um, Another BC would be this. So that's BC. There's another BC. That's C squared, and this is B squared. That should equal 2BC plus A squared. This is A squared. Each of this is half of BC. So if we just try to distribute them again, considering that we would get like the thing we had again, 4 of these would equal 2BC, and the remaining part of the figure seemingly would be A squared. These, which would be the relationship that we're going to obtain. Now we're just trying to do another simplification of the equation. So we have BC at both sides of the equation, and the thing we obtain is that a relationship between B, C, and A. The sides of the right triangle, which have their geometric significance over here, like B squared, C squared, and A squared. as we alluded to earlier. And if we just flip both sides of the equation, we would get that here a squared would equal b squared plus c squared. Well, we couldn't simplify it anymore, and this is the Pythagoras theorem relationship that we would have between the sides of a right triangle. So we would just have this form if we're gonna abstract it from any geometric meaning, and other concepts would be based upon it then in math classes, and so it would have its significance then and meaning in other forms of its application in sciences. But that's the essence of it. How that could be proved from observation, that it has its meaning in nature as well, because someone would grasp the content that he would have from the way he would aspire from living, and then he could relate it to abstract means. It may not depend on it, but that could be as a clue and something in nature, because that's the way everything is established. Perpendicular means the way someone would stand relative to the ground, the way the trees are entrenched in the soil, in the soil. So there is always a right angle relationship, because it's an efficient manner. Through things are related. Distances are always further apart. Dimensions are independent. This is a dimension itself. This is another dimension. Walking within a line, having another line relationship with it. So way means related in an efficient manner is through that right angle. I mean, it could be related to physics as well. But just a way of constructing stuff, whether there are some abstract or some actual tangible nature. This would be a straight path. This would be another path, but relative to this line, it could be related to it through other vectors, like one over this toward this side, another toward the other side. The one that's totally independent from it will be something that's perpendicular to it, having a right angle. Because it has no deviance from it. If we're gonna make a projection from this, or just to return the path of someone assume flat from the other line, it would have no deviance from it. It would return to the same point. someone walks from here to there, and he would just we're gonna flap this whole distance to the same point. Um, Someone would say, well, there was no difference that was assumed during the whole line relative to the other line. Um, and it's easy, someone could relate these both concepts by means of system of axes or some other way. It would be more simpler to be in this fashion, but this would be like another topic or so. And uh, and that's the formula that we got. This is the proof way how to think about it and to observe it, how to relate it to matters that are in nature and to the instinct someone would have in drawing stuff. Uh, and the thing they were based on is that on the area of a triangle and a square. So the multiplication of both dimensions, both sides, which would have its proof in another video. We're at the end of this recording, and thank you for anyhow for being consistent and watching and listening to it, and I hope that would had been of benefit, and because someone would need these concepts on how to think about it and in improving any relationship in at any stage, and it's a matter of advancing the thinking and grasping the material. Just to say that these stuff are not just based abruptly or on some uh, certain shallow observation, but they're nice, and it's good to know how these are formed, and to build other concepts, because someone just need basic matters in order to develop other complex stuff, and as he would proceed in his life, because he would learn other material and he have to apply it. So it's good to know. And we're done. And hope to see you in another video. Thank you. Thank you for watching. And have a great day.